Let's get to it. This is Module 7. This is our review for the exam. So I have a copy of the practice test. So I'm going to work through that and explain everything so you can watch this. You can just watch portions of it. If there's just areas you're struggling with, you can go back and rewatch problems you're having that you're trying to understand better. And let me know if you watch all this and still don't understand something. Come get with me and let's see what we can figure out for you. Here we go. Look at this triangle. And it says, what is the value of sine of x degrees? So this is our x right here. This is this angle right here. And it wants to know the sine. Well, we learned in the lessons that we have this acronym we can use, SOHCAHTOA. SOHCAHTOA, they were chanting around the bonfire before they disappeared, right in the story. SOHCAHTOA, which helps us remember our three trig functions and which sides the triangle that goes with, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So for the sine is opposite over hypotenuse. So the sine of the x degree angle, opposite. Which side? Well, the hypotenuse is always the longest side, right? It's always across from the right angle. We know that is the hypotenuse. So that's going to be the bottom of it, but opposite. Which side is opposite? This one or this one? Well, opposite would be the other side of the triangle. This is adjacent. Adjacent means right next to, right? If we have two things that are adjacent to each other, it means they're right next to each other. They're not opposite on other sides from each other. They're adjacent, not opposite. So opposite is 5 over 13. So right there, 5 divided by 13 would be the sine of x. All right, let's look at this next figure. We have angle x, and it didn't give us any side lengths. But it says if the tangent of x degrees is 11 over r, remember tangent is opposite over adjacent, opposite over adjacent, opposite over adjacent. And cosine of x degrees is r over s. Cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. So hypotenuse must be s. What is the sine? Remember, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. 11s. 11 divided by s, opposite over hypotenuse. 11 over s. Okay, we just had to fill in the sides based on what they told us. They told us what the tangent and the cosine is, so that should tell us the side lengths. We just fill them in. When you're taking the test, sometimes it's handy to have you some paper and just jot these things down, just draw that triangle and write those things in. Otherwise, you got to keep track of all that in your head. You might get confused. So, all right, so this picture shows a triangular island, and we have x, y, and z as the three sides of this triangular island and a 50-degree angle. So which expression shows the value of z? Z is right here. This is z, which is, for this triangle, it's the hypotenuse, because there's the right angle on the other side. Z is the hypotenuse. And so they're asking with sine and cosine. Sine and cosine. Well, with the hypotenuse, let's look at what the sine and cosine is. So the sine of 50 degrees, sine would be opposite over hypotenuse, right? Sine, SOH. Sine is opposite x over z. And the cosine of 50 degrees would be the adjacent. The y is right next to the 50, so it's y over z. So none of that matches this, because this is what's the value of z. Well, that means we need to have this be z equals. Until we have z equals, we're not going to equal any of these. So we have to rearrange. This is a lot about rearranging equations like we learned in algebra before. So if you didn't learn it very well, it's time to get good at it, because you're going to do it a lot from this point on in mathematics. So since z is on bottom, we have to multiply by what's on bottom. That's how you get rid of a fraction. You multiply what's on bottom. So we multiply by z. We've got to do both sides. And on both of these, we're multiplying by z. So right here, we have z times the sine of 50 degrees equals x. Over here, when we do that, we have z times the cosine of 50 degrees equals y. Okay, we're still trying to solve for z. So we're going to divide by the sine of 50 degrees. Same thing over here, trying to solve for z. Got to get z by itself. Right now it's being multiplied by the sine and the cosine, so we need to divide by that. So now those cancel out. We have z equals, oh, that's what we want. We're trying to figure out what z equals. It equals x divided by the sine of 50 degrees, or z equals y divided by the cosine of 50 degrees. That's what z equals. It's either x divided by the sine or y divided by cosine. It's not times, so it's not either one of those. Y divided by cosine of 50 degrees. There it is. Or y divided by the sine. No, y was the cosine. X was the sine. So it's not that one. Right there. Y divided by the cosine of 50 degrees. All right, let's continue on. All right, looking at some practical applications. This part of geometry, the trig portion, is very useful out in real life. It's used a lot by architects, engineers, just different folks trying to figure out these things. I used it trying to put some shelves into a trailer once. So the picture shows a barn door. So here's this barn door and has these supports. And so what's the length of support AB? That's the diagonal one. All right, so it makes a 45-degree angle. And we know it's 7 feet from here to here. So that is this side. That's that side of the triangle, 7 feet. 7 feet. So the support would be, there's the 90-degree angle. So the support is the hypotenuse. Let's just call it H. That's the hypotenuse. And we want to know what the length of that is. So with the 45-degree angle, since we're talking about this angle up here, which side is the 7? Is that the opposite of the adjacent? Was that 7 right next to the angle? No, that 7's right next to this angle down here. Right? This is the side it's right next to it. So this is not adjacent. This is opposite. So 7 over the hypotenuse is the opposite. So we need to be talking about the sine of 45 degrees. Because this is opposite over hypotenuse. SOH, sine, equals opposite over hypotenuse. So if we're talking about H, which is AB is H. We just called it H in our problem. We have to solve for H. So multiply by H because it's on the bottom. Since it's on the bottom, so you've got, when you multiply that, those cancel out. And you have H times the sine of 45 degrees. Not 450. Got to make my degrees smaller. 45 degrees equals 7. And then we divide by the sine of 45 degrees on both sides. So H equals 7 divided by the sine of 45 degrees. And the sine of 45 degrees is a number. We can put it in our calculator and find out what it is. 7 divided by that number would actually give us a length. But they're just looking for the formula here. 7 divided by the cosine? No. 7 times? No, there it is. 7 divided by the sine of 45 degrees. Okay. Let's look at this one. If the sine of 30 degrees is 1/2, then the cosine of 60 degrees is, and you're like, what? How am I supposed to know? Well, we should know very easily when we look at it. If this is our 30-degree angle, right, and this is a right triangle, so that means this is 90 degrees, right? 90 plus 30 is 120. If it's a triangle, it has to equal 180. So this one has to be the 60-degree angle. So this has to be the same triangle. 30 and 60 have to be in the same triangle. Because these two have to add up to 90, since this is already using 90. These have to equal 90 every time. So since they're in the same triangle, and the sine of 30, sine is opposite over hypotenuse. So the opposite is 1 and the hypotenuse is 2. That means the cosine of 60, cosine of this angle, cosine is adjacent over hypotenuse. Well, 1 is adjacent to the 60. And the hypotenuse is always the hypotenuse is always the hypotenuse. So adjacent over hypotenuse for the 60-degree angle would be exactly the same. Opposite for the 30 is adjacent to the 60. Remember, those trade places depend on which angle we're talking about, because opposite, if I move to this side of the triangle, it's not opposite anymore. this one becomes opposite. So it equals 1/2 because the angles are complementary. Since they're complementary, since they add up to 90, they're in the same triangle. So we know they're going to equal the same thing, in that case, the 30 and 60. Okay. Moving right along. Use this image to answer the following question. What relationship does the sine of x and the cosine of y degrees share? Here's the x degrees, here's y degrees. So the sine of x degrees, what is the sine of x degrees? Sine of x degrees, sine is opposite over hypotenuse. So from the x, the opposite side, opposite would be the 5. And the hypotenuse of this triangle is the 13. And the cosine of y, cosine is this angle now. So cosine is adjacent over hypotenuse. So adjacent to this y is the 5. It's the one right next to it. Over the hypotenuse, which is still the hypotenuse, which is still 13. They're the same because these two angles have to add up to 90 degrees. They're in the same triangle. They're complementary. So the ratios are opposites, identical. So they are both identical. They're both 5/13. We just calculated that. The ratios are both 5/13. All right, good point to understand there. All right, so here's two birds sitting at the top of two different trees. So the distance between the first bird and a bird watcher, which he's right underneath there, is 14.1 feet. And the distance between the bird watcher and the second bird is 27.9 feet. So that's the distance straight from him to the other bird. Is the hypotenuse of our triangle, 90-degree angle, hypotenuse. What is the angle measure or the angle of depression between the bird and watcher? So we're talking about this one up here. Since from the horizontal, it's looking down, that would be depression. It's being depressed. If it was an angle going up, it's elevation, right? We would elevate the angle. But since it's going down, it's an angle of depression because it goes down between the bird and the bird watcher. So then let's know that angle. Well, let's see. For that angle, this is the hypotenuse. And which side is this? Is that adjacent to the x or is it opposite? It is opposite. So the sine of x degrees would equal 14.1 divided by 27.9. Okay, so what is x degrees? We don't know, but we know what it equals. If we don't know what the angle is, but we know what the sine of that angle equals, then we can do that. It'll call it either arc sine in some textbooks, some calculators, or the inverse sine. Right? But in your calculator, there's two different ways the calculator show it. It'll either show it arc sine or it'll show it a little -1 sign with a -1 exponent. So the arc sine or the inverse sine is how it'll show on the calculator. So here's how it works. If we knew the sine of 27 degrees would equal a number. This is a number, 14.1 divided by 27.9. When we take it as a decimal, it would be a number, 0.5 something, right? 0.5 something when we divide those numbers. So we know what that equals. But if we just know what it equals without knowing the angle, that's when we use this to go backwards. So I can go to my calculator. So I can get where there's not a reflection on it, but you can actually see something. Let's turn on. All right, clear. So here's the sine button, but there's this above it, this second button. If you use the second button and hit the sine button, now see, it's got the little -1 up there. The sine, the arc sine, the inverse sine of what? This is when I know the answer. I know the sine of something equals 14.1 over 27.9. I know what it equals. I just don't know what it is. So I can say, okay, what's the inverse sine of 14.1 divided by 27.9? And that'll give me the degrees. So since we have that on there already, let's put on our formula there, 14.1 divided by 27.9. And it will tell me that is 30.3 degrees. 30.4, because it's a 0.35 would round up. So it's a 30.4 is the first one of our choices. Now I do want you to notice when you use your calculator, it should be a little DEG. Right, because if you don't you have DEG, RAD, or GRD. We don't want to be in radians or gradients. We want to be in degrees. So make sure it's in degrees because we want degrees as our answer. We don't want to know how many radians this is equal to. We want to know how many degrees it's equal to. So make sure your calculator is showing degrees at the somewhere on there. You should have a little DEG. So that makes sure we get the right number. 30.4. Okay, so the length of the shadow of this building is 100 meters. See, there's the shadow, 100 meters long, and it has a 45-degree angle from that point at the end of the shadow to the top of the building. Right angle. What is the height of the building? This is practical use. We could do this if we were at the school. We could go out and we could take the shadow of a light pole, and I could have you figure out how tall the light pole was. We could do all kinds of things like this by measuring the angle and the distance, how long it is. But this is an actual way you can do this, and it will work. So the height of the building. For this angle, the height of the building over here is the opposite side, right? That's the opposite side, and this is the adjacent side. So opposite over adjacent, that would be the tangent. So the tangent of 45 degrees, and we'll just call the height x. The opposite side will be x, equals opposite over, and the adjacent is 100. So the tangent of 45 degrees is the opposite over the adjacent, x over 100. Let's find out. We're trying to solve for x. We're trying to figure out this height. What's on the bottom of our fraction? 100 is. So we're going to multiply by 100. So 100 times the tangent of 45 degrees equals x, because these cancel each other out. That's what x equals, 100. Well, let's find out what that actually is. Go back to our calculator. We type 100 times, I'm going to hit the tangent button, tangent 45 degrees. 100 times the tangent is 100. That's a 100-meter tall building. Tangent of 45 degrees must be 1, huh? Check that out real quick. Tangent of 45 degrees is 1. And 100 times 1 is 100. So tangent of 45 equals 1. Next. Number 9. Don't have many more to go. This one's a pretty short practice test. A source of laser light sends rays AB. So this is A right here where the source is. AB and AC to opposite walls of a hall. And the light ray strikes the walls at points B and C. And they want to know what's the distance between the walls. Okay, so we got this light ray, and it's putting a light here, and it wants to know how far these are apart. And this is 40 meters up, where it hits this wall 40 meters up, and it hits this 60 meters up. Think about it, this is a huge hall. It must be outside or something, because 40 meters, that's over like 120 feet, 180 feet tall over here. So this is really huge. So we want to know how far apart these are. So let's look. We have two right triangles that we can use. And we have this 30-degree angle. So if we look at this one, 30-degree angle, and this is which side? Opposite. And we need to know this distance. We're trying to figure distance between those. So that is the adjacent. So we have opposite over adjacent. So let's call this one x, and we'll call this one over here y. So our tangent, opposite over adjacent is tangent, TOA, right? The tangent of 30 degrees equals the opposite, which is 40, divided by x, which is how far the adjacent side is. We're trying to figure that out. On this other one, we have a tangent of 60 degrees because we're also dealing with the opposite and the adjacent. We're not doing anything with the hypotenuse. Opposite over adjacent, which is tangent. So this is opposite of 60 over y. So there's our two equations to solve. We need to solve this for x. We need to solve that for y. We need it to be x equals. We need this to be y equals. Let's get rid of a fraction. We get rid of the fraction by multiplying what's on the bottom. Over here, that's the y. Over there, that's the x. Got to do that to both sides. So over here, x times the tangent of 30 degrees equals 40. Over here, y times the tangent of 60 degrees equals 60. Okay. We need to get just x, so we're going to divide by the tangent. Over here, we need just the y, so we've got to divide by the tangent of 60 because it's being multiplied by that right now. So x, these cancel out, equals 40 divided by the tangent of 30 degrees. And over here, y equals 60 divided by the tangent of 60 degrees. So what are those numbers? Back to our calculator. Okay, 40 divided by the tangent of 30 degrees. 40 divided by the tangent of 30 degrees is 69. We'll round it. How far are they gone? 2 decimals. 69.28. So that's how long this is. 69.28. It goes to right there, from the wall to right there. Over here, y is 60 divided by the tangent of 60 degrees. Oh, not 6 degrees, 60 degrees. There we go. 60 divided by the tangent of 60. And that equals 34.64. So this is 34.64. So which one of those is the answer? I got 2 different things. What did it ask? What's the distance between the walls? So I need to know from here to here. So I need to add those together because that is the distance here. That's the distance here. And if we put them together, we've got the entire distance. So let's add those together. 34.64 plus 69.28. 103.92, 103.92 right there. There's our choice. So pay attention when they give you these diagrams. Look and see which angle we're using. Are we using this angle here, or are we changing using this angle here, right? Because that makes a difference. Which angle it is, that's going to determine which is the opposite side, which is the adjacent side. Those will train places, opposite and adjacent, depending on which angle you use. See which sides of the triangle you're using so you know whether or not it's sine or cosine or tangent. And then pay attention to what they're asking. So we knew to use tangent because both of these used opposite and adjacent, opposite and adjacent. And we knew we needed to know x and y, those distances, and needed to put them together, distance between the walls. All right, let's look at number 10. Here's 2 ropes. AB and AD. We can focus here. Seems a little out of focus. All right. Are tied to a peg on the ground at point D. So here's our peg. Here, that one's tied there. That one's tied there. So that makes a 45-degree angle. That makes a 30-degree angle. And this is 5 square roots of, yes, that distance down there says 5 times the square root of 3. Right there. That's a number. 5 times the square root of 3. You want to know how far that is? Just to have something in your head. 5 times the square root of 3 is about 8.66, right? But this is an exact number. 5 square roots of 3 is exactly. This we would have to round it somewhere because this is showing us decimals, but it cuts it off at the 9th decimal. So the exact numbers here. That's why they use that instead of this. But it's a little over 8.5 feet. So what's the distance between points A and point B on the flagpole? Oh, okay. So we need to find distance this way. So we're looking at this side of the triangles. So let's look at the big triangle first, the 45-degree triangle. So this is from this 45-degree angle is opposite side, right? Opposite side. So let's say the big triangle right here that we're looking at, that'll be X. We'll call that X. And then we got this little triangle, right? See that little triangle in there? It also uses this side of the triangle, and we're going to call that one Y. But this one's only 30 degrees, or this big one's 45 degrees. So we have a little one inside of a big one. And for both of them, this is 5 times the square root of 3, because that's the same side for both triangles. So let's see the big one. What is X? So opposite and adjacent. We're not using the hypotenuse on either triangle. Opposite and adjacent. So again, we're talking about tangent. The tangent of 45 degrees equals the opposite, which is X, we don't know, over the adjacent, which is 5 times the square root of 3. So to solve this for x, we got to multiply by what's on bottom. That's on bottom. So x will equal 5 times the square root of 3 times the tangent of 45 degrees equals x. That's what x equals. Right? I think we looked earlier and saw the tangent of 45 degrees was 1. And then for the small triangle, the y, and remember this was the 30-degree angle, so the tangent of 30 degrees equals opposite is y, adjacent is again 5 times the square root of 3. Multiply what's on bottom, just like we did here. So that means y will equal 5 times the square root of 3 times the tangent of 30 degrees. All right, 5 squared root of 3 times tangent of 30 degrees on that side. And we do the same thing we do over here, multiplying both sides by the bottom. So let's put these in our calculator and see what they are. Okay, so 5, let me see up here again. 5 times the square root of 3 times tangent of 45 degrees. Tangent of 45 degrees is 8.66, which we said is exactly what 5 squared root of 3 was, because tangent of 45 degrees we said was 1. So how about this one over here for y? So this is what x is. This is 5 times the square root of 3 times tangent of 30 degrees. Let me close that parenthesis just so it's happening. Times tangent of 30 degrees. That equals 5. So y is 5, x is 8.66. Now what's it asking? Let's go back to what is it asking? What is the distance between points A and B? Well, B, we know the height of that, because we just figured it out right here, is 5. This is 5. That's how high off the ground that is. This is 5 right there. And how high is A? We said it's 8.66. That's what we figured out right here. The x was 8.66. So this is 8.66. So if we take 8.66 and we subtract the 5 down here, this is 5, how much does that leave? First choice, 3.66. We just have to subtract that in this case, because that's what it's asking. 8.66 minus 5 is 3.66. You have to read it, look what it's asking, draw it if you need to, have some scratch paper, make sure you understand. All right, here's our last problem. Max observes the zoo and library from a helicopter flying at a height of 300 square roots of 3 feet. 300 square roots of 3 feet above the ground. That's how high his helicopter is. What's the distance between the zoo and the library? Okay, so again, we're looking at a distance down here. So we've got the smaller triangle. It has a 60-degree angle. And we need to find out how big this is, x. And we know this side is 300 times the square root of 3. And then we also have the bigger triangle, which still is at 300 square roots of 3. We're going to call it y. And this is at a 30-degree angle. All right, 60 degrees and 30 degrees. I just took them and broke them into 2 separate triangles just so you can see them. So to find x, for this angle, that's the opposite side. And that's the adjacent side. For this angle, that's the opposite side. That's the adjacent side. So tangent of 60 degrees equals opposite, 300 square roots of 3, divided by adjacent, x. Over here, the tangent of 30 degrees equals the opposite, 300 square roots of 3, divided by y. I don't know why I have this big blue line down the page, but there's a big blue line down my page. Okay, we have to solve this. What's on bottom? The x. Multiply both sides by x. So here we have x times the tangent of 60 degrees equals 300 square root of 3. Over here, multiply by y. We have y times the tangent of 30 degrees equals 300 square roots of 3. Getting closer? We want x by itself. Right now it's being multiplied by this, so let's divide by this. Right? And then we got to divide by the other side. Same thing over here. We want y by itself. Right now y is being multiplied by the tangent of 30, so we're going to divide by the tangent of 30. So what does x equal? X equals 300 times the square root of 3 divided by the tangent of 60 degrees. What about over here? Y equals 300 times the square root of 3 divided by the tangent of 30 degrees. Let's put that in some real numbers. X was our small one. X is going to be the zoo. So let's just say the zoo is how far from the helicopter, because that's from this point right here. That's straight down from the helicopter. The zoo is 300 times the square root of 3 divided by, this time, divided by the tangent of 60. That is exactly 300. And talking about feet, 300 feet. That's how far the zoo is from the helicopter, 300 feet. How about the library from the helicopter? Remember, it's y, it's from the helicopter. So it's this whole distance right here. How far is all of this distance? It is 300 times the square root of 3. Oh, not make the wrong one. 300 square root of 3 times the tangent of 30 degrees this time. Oh, it's not times, it's divided. Ooh, don't want to make that mistake. We were doing that before, multiplying. Make sure you're dividing. Divided by tangent of 30 equals 900 feet. So this distance is 900 feet. So make sure you know what you calculated. We calculated this is 300 and this is 900. What's the distance between the zoo and the library? If the zoo's 300 feet away, how much farther do I have to go to the library to be 900 feet? 600 more feet. We subtract those. 900 minus 300 and gives us the 600 feet. We're done. That's it. That's the last one. All right. Pay attention to your angles. Make sure you know which angle of the triangle you're using. Pay attention to your sides, opposite, adjacent. Those will change, right? Depending on which angle. Opposite becomes adjacent if you switch to the other side of the triangle. And the hypotenuse is always the hypotenuse. Make sure you're reading to see what the question's asking. And, if you need to review any of this, please do. If you're still confused after this and you have a specific problem you need help with, get in touch with me. Come to class or email me. We'll set up a time. Do that before you take the test. Don't get in the test and bomb. If you can't do it on the practice test, then you need to figure it out before you take the test, right? So get it worked out. All right. We will see you next time. Do work you can be proud of.